Hey guys, welcome back to another weekly update. This is going to be kind of a short one because, as you can see, I did a lot of work this week, but it was pretty much all in one thing. Barring a little bit of progress in E1M3, it was really all building the saving and loading system, which wound up being way more complicated than I thought it might be. Now, by this point in development, I probably should have known better that there's just no magic button that does things for you. As a player, saving and loading, that really is just a magic button that does things for you. So you press the save button, it records everything, you press the load button, and it brings everything back to the way that it was. But there's kind of a problem from a development standpoint. You have to define everything that gets saved, and then you have to store it in a way that it can be accessed later, and then be loaded in and applied. So looking at the list here, we've got save loading the player, save loading the enemies, save loading weapon, ammo, health, armor, and key pickups. You have to save everything about every object that you want to save and load back into the game. So once you have it figured out, it's a lot of busy work. The two main ones that were a lot of work to figure out were the player and the enemies, and they each have their own little quirks for that. So save loading the player. That one was mostly figuring out how to set up the systems, and a lot of the main calling system for telling the game I want to save or I want to load is in the player's blueprint, because the player never really changes. So you can use that for things that are more consistent with the game. One of the big problems was figuring out, okay, so we have to store what weapon the player has out at the time. You also have to store what weapons the player has ever picked up at that time. You have to store what kind of keys the player has. And when you load, you say you originally only had one key in your save, but you picked up two more when you started to load. You have to make sure that you clear those keys out of the player's HUD. In fact, you have to then figure out what weapon the player was holding when you saved, and then seamlessly switch the weapon that you were holding from starting the load to when you saved. That includes also things like your ammo display, making sure that that's correct. And so I had to figure out how to consistently and cleanly reapply the weapon that was out. So I had to kind of build a system for that, and that actually had the added benefit of me cleaning up the code a bit more and making it more efficient. So at least something good came out of that. Enemies were really what gave me the most trouble, though. Is if you think about it, enemies have the most variables out of anything else in the game because they have their behavior tree. They've got certain states that they can be in, like, have they seen the player? Are they mid-attack on the player? Have they seen the player, but they don't see them anymore? Have they heard the player? Things like that. You have to save all of that and keep that consistent between saves and loads. And one of the problems with that is that because there are multiple enemies, you essentially have to delete all the enemies when you go to load the game, which means that you are technically respawning brand new enemies and having to apply all those variables to them in a way that's consistent. So figuring that out took a bit. Fortunately, that also led me to look at the code really closely and made me find some issues that I was running into there. So I fixed those, and now the enemy code is a bit more efficient, so that's nice at least. Unfortunately, once I had the enemies dealt with, things like the pickups, the weapon, the ammo, all the keys, all of that is way more simple. It's essentially just the same process as the enemies, but a tenth of the variables. So it's a lot easier, and then that just becomes kind of busy work. So that's where I'm at right now. But I want to get into the game and kind of show you some of these systems that I'm talking about, because it really is not what you think it might be. Let's go ahead and get into the game. All right, welcome back to Unreal, and welcome to your save file. Yes, this is all there is in your save file. It is just a collection of variables on the side here. You see things like level name, so the name of the level that you are saving. And then things like S player save and S enemy save, which is the same color but a different picture. So this little blob here means that there's one entry, and this grid here means that it's an array or a list. So it's a list of different data entries. But what is S player save? S is structure. So a structure is a collection of variables. This is all the information that the player is saving. Now, why use the structure? Because otherwise, if we go into our save game file, we would have to have, player health, player armor, player location, a different entry for every single possible variable for the player. This way, we have one entry. So it is a lot cleaner, and it is actually a lot more convenient, too. So what information do we need for the player? We need their transform, which is location, rotation, and scale. Camera rotation, because the camera is attached to the player actor. So the actor might rotate, and, the camera is bound to it, so the camera rotates with it. But what if you did not save the camera rotation, but you saved the player rotation? You could wind up skewing the camera. So that way we are just keeping it consistent, and we are making sure everything is saved. Never switched, weapon class, and weapon enum. Those are for storing which weapon you currently have when you save, and for applying the correct weapon when you load a save. Weapon equipped is essentially just it's a number that we use to reference that in weapon pickups and ammo pickups and the HUD. So that way we just have a number that's associated with each weapon. So that way it just knows which settings to store. Got weapons, so it's a Boolean array. This is saying, this is essentially to look at a list and do a little checkbox. So if we try to pull out the shotgun, but we've never picked it up before, then we obviously can't have it. So we can't switch to it if we have never picked it up. That is there basically to just make sure that you don't try to pull out weapons that you don't have. Or more importantly, the reason why we save this is you don't want to be able to not pull out a weapon that you do have. So we want to keep this consistent. Health, obviously. Armor, ammo. These are for level stats. So found secrets, max secrets, killed enemies, max enemies. That's all stored with our FPS player. Our keys. And then fall begin and was falling. These two are important for something that you might not really think that you need to save, but makes a lot of sense when you think about it. You need to save. So imagine you're falling off a tower and you quick save right before you hit the ground. You could load the game, and when you load the game just detects, oh, they just started falling. They only fell 5 feet. When really you jumped off a tower. So you need to save the information of where you were when you started falling. So this way it keeps fall damage consistent. So we've got all that information. We've got that stored in our save. We go into our game instance here. This is what actually handles a lot of the code for saving and loading. And the reason we use the game instance is that it loads before basically anything else in Unreal. So we're able to start setting up save data before it can ever be used. And this is all just essentially creating a save game for a save slot. And loading, making sure it exists. Now we are looking at save game data, same thing. We are setting a save slot to save in. I don't have any UI made right now, so really all we have at the moment is a quick save and quick load. But we could make whatever save slot we want. Right now we just have the quick save slot. And we are going to access that mainly in our player blueprint here. So we go into our player blueprint. We have our quick save button, which checks to see if we have a valid save to prevent errors. And then we are telling the game instance blueprint to set the quick save slot, or set the save slot to quick save, because this is the quick save button, so this is the only save it will ever be associated with. Clear all, we go into our game instance here. Clear all is clearing out those lists of other things that we've saved. This way it prevents there from being any old data that could get drug into our load. So we want to make sure that these are empty. So it erases everything in these lists. We don't have to do that for the player because, as you note, these are all lists. The player just gets overwritten, but for instance, enemies save, we might have 30 enemies when we made one save, but then when we go to save again, we might only have 5. So we need to make sure that we clear all these entries out so that we only get 5 enemies in a list, and we don't have 25 other potentials that could get leaked in. Get rid of that. Call a quick save. This is basically the way of telling other blueprints, hey, we pressed the save button, we're saving, do what you need to do. So that gets referenced by really everything. Everything that gets saved will use this. Then we are getting our player save, which is a function that just records all the information that we need. And going into save player, which is in our game instance here, and save player, very simple. It's just setting your player save data in your save game, or your save file, really. Now we go back to player. We go back here. We're doing the same thing with the level name so that we will know what level we're on in the save. And then we are saving the game data. Now loading. Well, actually, let's first go to the enemies here. And you can see right here, that's the call that we're talking about. So when we save, we're getting that call to do the quick save event, which we look down here, is just getting enemy save and sending that data over to our game instance. And the enemy save is this information with this right here, which is extremely important. And I'll explain what it is in a second. So we are going here, we are getting the information from the enemy save. But first, we are getting all actors of class. What that means is we've got our BP enemy, that's blueprint enemy, blueprint. And this is all the information that an enemy could ever use. So if you imagine an enemy that could do literally everything that we have ever coded an enemy to be able to do, this would be them. We don't have any enemy that can do that, though. And this blueprint never actually really makes it into the game. We never spawn anything as BP_enemy. What we do is we have other blueprints, and we tell them, use this BP enemy blueprint as a template. Everything in there is what you're going to look at. And what we do is we set up different stats and values and settings in those enemy blueprints so that they know what they are allowed to do based off of everything in here. So we have your bug enemy that we talked about before. We've got them, and then we've got our pistol enemy. And they all use this blueprint, but they're very different. So they are what they are actors of the BP enemy class. So this is essentially telling us, and let me go back into the enemy blueprint here. Remember when I said this was very important? So we are saving what class that is. So we are saving if they're a bug or if they're a pistol enemy or whatever. So we are getting all the enemies in the level. Out actors is putting them out as a list, and we are looking at that list and saying for every entry in this list, we want to add a unique list into the enemy save data list, which, as you remember, it is empty right now because we cleared it. And so we are taking, so what are we adding in? We are adding in the information, the data that we got from the enemy, putting it in there. So we are creating a new entry in the list with that data. And then once that's done, we save the game. So now we go into our player here. And what if we load the game? This is to clear out noises, because I can mess with the enemy's behavior tree. Calling quick load. We don't use this right now, but we might at some point. Then we are getting the player save data. And then as game instance, we are setting the quick save slot. So that is making sure that we are getting the quick save data. Then we are going into get the current level name. So we're getting the level name and we're checking, are we on the same level as the save? And if we are, then we are going straight to the end here. If we are not, then we are going to load the level. This way it makes the save loads way faster if you are on the same level. Then we are using player save, which is setting it's getting all this data and then setting all these variables for the player. So that's actually applying it. Load enemies. We go in here and load enemies. What this does, we're getting all actors of class, so we're getting all the enemies, and we are deleting them. And the reason for that is, if you put like 5 pistol enemies into a level, you'll have pistol enemy 1, pistol enemy 2, pistol enemy 3, pistol enemy 4, pistol enemy 5. And that's how Unreal will name them. So you could try to say, pistol enemy 1 will always have like these settings based on what they saved. But the problem is that there's a couple of problems. One of the problems is that when the game starts, then they will have default settings. So they won't have all these things saved. You can't really keep things stored in a blueprint between loads. Or like, if you stop the game and then start it up again, then it resets everything in blueprints to defaults, which is why you need to have it saved outside of the enemy blueprint. This is why we aren't storing this information inside the enemy blueprint. But there's another problem. Say you could say that enemy 1 will always have, these stats. The way that Unreal names them, it's not consistent. By that I mean, who was pistol enemy 1 in one run of the game could later become pistol enemy 3. So then you'll wind up with weird like combinations and enemies having stats and being in places they shouldn't be. So this way you're able to just delete them all, not have to worry about it, and then you are looking at how many entries are in the enemy save list, and then another for each loop, spawning an enemy with the information that was stored there. And this is why the enemy class is so important to save. Because this way, you're saving an enemy class, you're able to say, enemy, pistol enemy spawns with these. And since everything's a unique entry on the list, even if, pistol enemy 1 isn't who they always were, you'll still have a pistol enemy with pistol enemy 1's stats. It's essentially just keeping it all the same. And so you have to do that for everything. You have to delete, like for your keys, you are deleting all the keys and then spawning a new key where the old ones were, assuming they existed. Go back into the player list here, and we've got load enemies. So load pickups, and load pickups is going into game instance. Here we've got load pickups is load weapons, ammo, health, armor, and keys. And the reason why I have them listed to execute here is because we go into our player list, we look at all this information that's being stored. This might seem like a lot, and for enemies, this might seem like a lot, especially if you have 30 enemies, but this is all really, really simple data, and it's not a lot for a computer whatsoever. So we basically have instant saves and loads. But even if you have so little information that it's just an instant save and load, if you call that information with delays, then you might be able to execute the information. So you might be able to set the save really fast. But if every piece of it gets delayed a certain amount, then you're going to have slow saves, no matter what. So this way, every time that you call an event to happen, you are introducing some amount of delay. Not much, but some. And over time, that can start to add up. So if you have a list right here, we'd be saying use. So we're setting the player information. Then we are loading the enemies in. And then we're loading. So if we didn't have this, we would say, after we load the enemies, then we are going to load the weapons, then load the armor, or the ammo, then load the health, then load the armor, then load the keys, and then we're going to load, whatever else. And then we're going to, FPS player, then we're going to update the HUD, which is more of this. So then we're going to update the health, we're going to update the ammo, we're going to check our weapon, and then we're going to update our keys. And so you start building in delays, and you start making your code slow just because it's fast. It's fast to execute, but it's slow to call it. So this way, we just call load the enemies, so load pickups, and that means that while we are loading all this information, all we had to do was just call this, we just tell this to start. And then we move immediately over there, so that way we can have this loading at the same time as this. So you're able to do things at the same time rather than one after the other. So it's just kind of an efficiency thing. But that's really about it. I could go forever, and I've had to redo this a couple of times because it just goes on and on, because this saving in games is actually way more complicated than I ever thought, and I kind of get a little bit more appreciation for games with really fast saves and loads and everything that works correctly. Really, I'm kind of surprised that we don't see more issues in this department. I guess really it's not too bad once you know how to do it, but figuring it out, I mean, it's a pain. And I actually really can understand why in Stalker, for instance, the time of day would completely change, and enemies who are hostile to you would suddenly become neutral again between saves and loads. Things changed all the time in those games between saves and loads, and now I really understand why. because a lot of it happened to me when I was working on this. And that's it for this week. Thanks a lot for watching, everybody. Make sure you follow the Twitter account so that you can get more frequent updates. And I will see you guys next week. Have a good one, everyone.